Yeah. So the first thing we're going to come back and talk about is just generally speaking logarithms. And so this first row of this column of examples that I have first is uh, pretty simple logarithm to exponential conversions. So anyways, today is what, 11.7, and we are today going to be going from exponential to logarithmic. And note that um, the arrowheads on both sides. So we're going to be going both ways throughout the course of this lesson. We're going to be going from exponential to logarithmic. Do you guys even remember by chance what a logarithm is?
It's how you pull the exponent down.
Yeah, good. So we did talk enough about that. That was that yesterday that you remember that logarithms enable us to do things that we're not otherwise legally allowed to do. So real basic stuff here. And again, I have 17 of these examples. I don't intend to number them, but you can if you want. So the first one is I'm going to give you a logarithmic equation. And the rust will come off quicker than maybe you think it will, because there we do a whole big unit on this in Algebra 2. It's just been a while, so you forgot. Does anyone remember me ever using the words water cycle?
Yeah.
The water cycle diagram is the thing that I always use. I feel like that analogy works to help us remember how logarithms work. With logarithms, the way they work is that if I wanted to convert an exponential equation into a logarithmic equation, what I would do is I would take the 8 and I would raise it to the power of y, and I would set that equal to x. You, it's been a while. Like I said, there's probably a pretty small chance that you remember that little thing. But if I wanted to convert this logarithmic equation into an exponential equation, poof, just like this, I can now say, oh, so you mean that 8 to the y is equal to x? And the answer is yes. Is that ringing any bells, even faintly? When we want to convert a logarithm, I mean, let me give you maybe I'll give you a simpler example. How about this? Uh, I'm coming back to this example, by the way. So put that one on kind of the back burner and turn the heat down a little bit on it and let it simmer. We're going to come back. So let me jump aside and give you something like this. Um, log base 5 of 25 equals 2. That is a fact. That's just as true as saying that 2 plus 2 equals 4, or that 9 divided by 3 equals 3. So is anyone able to piece that together and illustrate? Right, just employ the water cycle again. And the way it works is you take the base of the logarithm, you raise it to the power that is the quote unquote answer, the thing flying solo on the other side of the log, and then you set it equal to the argument of the logarithm like this. My water cycle on the first problem looked a little bit longer, and that's just because I had the y, the solo number on the other side. So it had to give a little extra stretch to get there. But the pattern never changes. It's always base to the logarithm equals argument. Like it's always the same, base to the solo guy, if you will. So that's why I could say, okay, here I can prove it to you. 5 to the power of 2 equals 25. And you can go the other way as well. Like you would agree, I know you would, that 8 to the power of 3 is equal to 512. Like that's a math fact in the same way that 2 times 3 equals 6, right? So could you take that exponential equation and convert it to a logarithmic equation?
Log base 8 of 512 equals 3.
I just could not have expected you to say that so boldly and quickly and confidently and perfectly. That was so beautiful. Log base 8 of 512 is equal to 3. Nice, well played. If you feel like you've never seen this before, I hope that as we work that you start to feel more and more like, oh yeah, I remember this now. Like it was near the end, very near the end of Algebra 2. It was one of those sort of April-y things that we did, March, April. Coming back to you yet? I saw you shake your head earlier a little bit. Say again, Coop.
Oh, me and Webber are missing the hand code during that one.
Huh, rad. Sweet. Um, so that was like a couple years ago.
Last year.
Oh, that was just last year, wasn't it, that I
Yeah.
had you guys? That's right. I forget that the transition from that class to this class isn't all that long. I'm kind of a knucklehead. So, where are we at with this? Can I go back to example one? Okay. So the goal for the day, I should have been a little bit better when I wrote the topic for today. Yes, we're converting exponential to logarithmic, but really what we're doing at the end of the day is we're finding inverses. That's really the goal of this part of this unit is for us to be able to take any function and invert it. Every function has an inverse function, and our goal is to find it. And the thing about it is like, that like exponents and radicals are inverses, times and divide are inverses, plus and minus are inverses. The same can be said of exponents and logarithms. Exponents and logarithms are inverse operations of each other. So if I can figure out a way to find the inverse, well, in order to find the inverse of a function, I simply need to switch the x and y and resolve it. And that involves converting from exponential to logarithmic. So let's get back to this example. So back to this fella here. I'm going to erase a whole bunch of this stuff and we're going to go back to this guy. So if this is the original problem on the board, the first thing we're going to do, you might remember this, when we go to find an inverse is we're going to swap x and y. So these will be a little bit tougher today, but once we groove through these first couple, the next few ought to be slick and quick. So if I switch this logarithmic equation um, to invert it, it'll say x equals log base 8 of y. I mean, just without negotiation, step one is to swap your variables. That's how we invert, right? And now it's time to dig in and resolve it for y. Anyone want to take a shot at solving this for y? What an absolutely wonderful leap you just took. Yes, if you apply the water cycle to this, it's very nice that actually the y can, I don't want to say it separates itself, but the nature of this is that when I convert it from logarithmic to exponential, naturally the y is going to kind of fly away and detach. And the water cycle says that this to the power of this equals this. Like that's just never going to not be true. Well played there, Bryn. And so we can say that I'm going to do it in the water cycle order. 8 to the x is equal to y. And that it is a function. Yep. Did I answer your question? Yeah, these are both actually functions. This is a function, and this is its inverse function. You okay, Allie? Yeah. Okay. Awesome. I know. Sorry, it's that soothing sound of my voice teaching you these exciting things about logarithms. Let's do another one. I'm going to keep this one. I was going to make a jump here, and I'm not going to. I keep calling audibles. I can tell it's not going to be the last time today. So let's do y equals log base, I don't care, 13 of x. What's step one?
Yep, the next one.
Absolutely. So x equals actually log base 13 of y. Next step.
Quarter cycle.
Mhm. And so what's y going to equal?
13 to 5.
Just like that. So moral of the story is my teacher gives me green equation. I swap variables, resolve, and voila, I have his inverse equation, inverse function. This one might trick you a little bit. Let's see if you catch it. Something's missing, right? And I didn't forget it. Anyone, again, impressive if you remember this, but say it again. Nope. There's a missing base and it is 10. Yeah, it's hard to remember stuff like that. But remember that when a logarithm, an log logarithm, does not have a base, it actually does. It's always 10 because we work in a base 10 number system. So 10 is the default logarithm. Um, so if you rewrote this on your own, I mean, I'm going to do it because I'm the guy with the fake pen, but it really does have a base of 10. And so we're going to swap our variables. X equals log base 10 of y. And what's the inverse function? There you go. Y equals 10 to the x. Done. So that's our three complete and total warm-ups. Is everybody okay to this point? Okay. So we're going to just see little incremental steps in difficulty as we go through the next like half hour. So here's our first little jump. It's not bad. Y equals log base 4, and I mean not bad at all, of 3x. All I've done differently this time is I've given a little bit of oomph to the argument of the log. Like it's not just x. Whoop-de-doo, right? Step one, swap them. X equals log base 4 of 3y. Next step,
Was
hit it with the cycle, right? And that's that conversion when we're jumping from logarithmic world to exponential world, it's that water cycle sort of vibe, that movement, that little circular motion that we do. So we wind up with 3y equals 4 to the power of x.
and then
And then we just divide by 3. You know, Al,
I definitely like 1/3 times 4.
I'm not,
I
yeah, I mean,
think
God, you're a good learner. Eventually, yeah, when we get down to graphing, I think I'm not going to stress over that today, but what a amazing thing to say. So today, I'm just gonna do it like this. But Cooper, you're so correct. Like when we go to graph, that's going to be a 1/3 vertical compression. Love it. So it's just not really the target for the day. So if I can get you guys through this to the point where like you could look at me and say every example kind of made some good sense, that is mission super accomplished today. So nice so far. Okay, next one. Y equals log base 6 of the quantity of x plus 2. You do start to see that. I mean, and I don't want to encourage you to do this because I don't want to get the blame, but there comes a point where you can start to see the swapping of the variables and the first step happen simultaneously. I'm not going to force that issue with you, but yeah, we got to swap them. So x equals log base 6 of the quantity y plus 2. And the idea here is like Y is currently trapped, right? Like I want to get him by himself, but he's like, hey, I'm part of a log here. Like you got to bust me out. And how we bust him out is the conversion, right? The water cycle. So, and I keep switching sides. I don't know if you noticed that, but I'm pretty compulsive about getting my Y on the left. So I'm going to put my Y plus 2 on the left. What's the right side going to say? 6 to the power of X. Last step. So we get Y equals 6 to the power of X minus 2. And because that minus 2 is where he's at, he'll be a vertical shift when we graph, not a horizontal, right? All right, you ready for the next transition? Okay, so that was my easy version. That's like level 1 or level 2 of converting logarithmic to exponential. And if you're paying attention, you probably know what we're going to do now is we're going to go the other way. So I'm going to give you an exponential, and you're going to help me find his inverse. So again, if we use exponentials to invert logs, then we're going to use logs to invert exponentials. Make sure all those words came out in the right order. What do we do first? Swap your variables. X equals 8 to the y. Okay. Step one, swap. Every time, swap. This is where you have to be really good at really understanding logarithms and know how to do the water cycle in reverse. And Coop, you nailed this last time, so someone else has to answer it this time. What is the logarithmic version of this equation?
Y equals probably like log base 8. Okay?
Couldn't have said it better myself. Y equals, so the exponent is going to become your solo guy. Log base 8 of 8. Log base 8 of x. Did I say 8? My bad. Sorry. Well played. And just like that, poof, we have an inverse and we're done. Okay, let's go again. Let's do y equals 4 to the x minus 3. Step one, Swaparooski, right. So we're going to have x plus 3 equals 4 to the y. And that might have triggered a couple of you, like what happened there. But I feel like if we find little moments where we can shave a couple seconds off, like you're going to have to turn around and add that stupid 3 back, right? So no harm, no foul, and just doing a couple little things. I wouldn't go danger mode, like, trying to conquer the world, but little things like that, easy peasy. And now it's time to hit it with the water cycle. So who's going to be the solo guy? the y. The exponent is going to be your solo. So y equals, and it's log base what? Nice job. Nice job. And once, the next logical step after today and Monday, once we get the algebraic side of this down, the next step is I need to show you how to graph logarithmic functions. They're not hard at all. Once we recall what logs are. No, we never graphed logs last year, I don't think. No. Mm-mm. Maybe I'm wrong, but I don't think we did. Okay, let's keep going. Take a break after these next couple, just a real short one, just to let your brain clear, get a drink of water, whatever, something like that. So let's do y equals 5 to the power of 2x. What do we get? Swap it first, right? X equals 5 to the power of 2y. And then employ the water cycle. What's it going to be? There you go. 2y equals. Good job. And, you see some basic algebra. Thank God we just know how to do basic algebra. Like, how do we finish the job here and get y by itself? Right. So our final answer here is that the inverse y is equal to log base 5 of x, but divided by 2. Basic algebra. 2 more examples, and then again, just a short break. Okay, I'll leave this up on the screen and I'll just go to the side and I'll switch colors. So let's do y equals 3 to the power of x over 4. I'm sorry to keep asking you to do this. Part of me wants to stop writing them this way because, the first step is always the same, but I think that it would feel wrong to just write them with the variables swapped. So I apologize, but we're just going to keep doing that first. So the real thing here is x equals 3 to the power of y over 4. Right? What's that water cycle going to say? Do you know?
Why?
You don't know? Let me tell you how to do this, okay? The first thing you're going to do is you're going to take the exponent thing, and that's going to get its own side of the equal sign, okay? That's called the logarithm. So we're going to take y over 4, and we're going to bring it down and set it equal to, okay? Now, the next thing we're going to do is we're going to have a log. The question at this point is, what is the base of the log? Well, you know that in an expression like this, that 3 is called the base and y over 4 is called the exponent. So the base of the power is also the base of the log. Are you with me? Okay. And then the argument of the log is the idiot flying solo over here on the other side, in this case, x. Got it? Okay. And then again, simple algebra. How do we get y by himself? Multiplied by 4. Now, I'm going to tell you something here in a second, that this answer is not correct. And I'm going to see if anyone, by some freak chance, remembers why. It's actually not incorrect. It's just not done. Do you know?
I don't know, but you multiply 4,
Nope.
4,
You do this. This is one of those obscure little things that, like, who in their right mind would really remember this? But this is what you and I were talking about, is that remember that logarithms enable us to tinker with exponents. If the argument of your log has a power, then that exponent can come down. And conversely, if you have something in the front, it needs to go back up. So a simplified, acceptable logarithm would look like the bottom one, not the one right above it. Okay. One more, and then we'll just take a short brain break here. The lecture was supposed to end at this point, but I just thought that we could do better. So last one, and then short break. I'm so sorry to have to ask you this. In fact, I'm not going to ask you this. I'm just going to swap them. Take that. Okay, get it myself. Thoughts on this one? You would. And this example made it onto the note card because I thought that some of us might have been inclined to hit it with the water cycle, but this is not ready for that yet. The power isn't by itself. And that's really what green lights us to water cycle, is we've always got the exponentially part alone. This is not like that. So this 3 has to take a dirt nap. And the way we do that is we multiply both sides by 3. like this. And that'll leave us where we want to be. So our left side's going to say 3x and our right side's just going to say 7 to the power of y. It's at that point now that the water cycle makes sense. So what's our log equation going to say? You got this one, JB? Log base 7 of, that's how we do it, just like that. Okay. You just got to remember, like, it's hard to keep track of all the parts and pieces, and all I can do is just give you kind of guideposts along the way. So step 1, remember your exponent becomes the guy that gets his own side. The base of your power becomes the base of your log. And if you remember those two, then you just fill the last one in the only logical spot left. So let's take just a couple minutes if you want. Just get up, walk around, go get a drink of water, shake your head out. I'll pause this and then we're going to finish up. They get a little bit harder, but you're tough. You can handle it, right? You're not scared. Huh? Go. Yeah, go get your potty on. I'll pause this. Nothing. This is going to take the last 14 minutes. So this is all we're doing. And then we're going to promise to not forget all this before Monday. And then, oh, Lordy. And then Monday, I'm going to have an assignment for you. But the good news is these problems are just like the assignment. So you should not have any surprises. All right. So we're going to level kind of 3 or 4 now. They're going to get a little tougher. Not a lot tougher, just a little. So for these next few examples, we are back now to converting from logarithmic to exponential. And we're kind of at the final level of difficulty, but I will say in these I don't think we'll get through all of them, but they vary a lot. Like some of them, I did them earlier and I was like, well, not bad. And then some of them I was like, wow, that was pretty bad. So let's give it a shot. Step 1.
Flip them.
Yeah, we're going to switch them. So x equals log base 5 of the quantity of negative 2y. Yeah, and they're right. I should have just put x plus 6. I don't know what I was thinking there. So I'm going to waste a step here, and we're going to move the 6 to the other side, and we're going to have x plus 6 equals log base 5 of negative 2y. Next step. Yeah,
Where's the negative find there?
it's fine because it's a variable value. So I mean, you can't take a logarithm of a negative, but if y is a negative, then that's a moot point. So you know what I'm saying? So the fact that it's a variable value means we're still fine. And no, we don't really want to get rid of it. We're just going to ride this out. We're going to hit it because the logs, everything's by itself like we want it to be. So what's the water cycled out thing going to look like?
Negative 2y
Mhm.
equals 5 to the power of 6 or x plus 6.
Well played. Right. And so they start to feel like if you're someone that gets a bit nervous about math, that probably feels now like we're going someplace that maybe is a little harder, but the mechanics really aren't changing. And then the last thing we have to do is just divide by negative 2. So we wind up with the inverse y is equal to 5 to the power of x plus 6, all divided by negative 2. Okay. I'm sorry. You want me to pull the negative out for you? Okay. You don't let the problem hear you say that. You'll hurt his feelings. Let's try this one. Do you want me to just to start switching X and Y or should I not?
Yes.
Is that bad? Okay, so I'm saying this for the recording and for you guys that I'm writing these problems with the X and Y already switched. Take that, math gods. So here it goes. It's already switched. Look at us. I feel so rebellious right now. Like I'm having honestly, yeah, like my pen is having a hard time moving. Like, okay, there we go. Oof. I did it.
So proud of you.
Thank you. What's step 1? Don't you start with me, punk. What's step 1?
The multiplier, the negative 3.
Yeah, your instincts are strong. The negative 3 cannot be there. So remember, certain things have to be alone before we convert exponential, logarithmic, vice versa. That negative 3 is the reason this problem exists because I want to make sure you guys are clear. That's got to go. So we need to divide both sides by negative 3. So our next step is going to say x over negative 3 is equal to log base 4 of y cubed. What do we do now? Yeah, it's time to convert now. So what's it going to say?
Use y to the third.
Yeah, equals
Four. Four to the power of x and negative.
4 to the power of x over -3. Yeah. Right? Good.
And then what do you want?
Yeah, so this I flagged this one on my note card just to say this is going to be a moment where I wanted to give you a break because was hoping your brains are still going now. I don't want to call this a cube root. What I want to do instead is I want to raise both sides to the power of 1/3. And at some point in your math education, whether I hope it was me, but someone probably taught you that taking the cube root of something is the same as raising something to the power of 1/3. And so the fact that that is true means, and there's because this is just a cleaner way to do this. So what we're going to do is we're going to raise the left side of this problem to the power of 1/3, and we're going to raise the right side of the problem to the power of 1/3. And so that's exactly the same as cube rooting. And the reason it works is because these two little things up here in the yellow egg, those are reciprocals. So when you multiply reciprocals, they kill each other. So we're left with y equals 4 to the power of -x over 9. And honestly, there's a little bit more that we could do with that. But at this point, I made the choice. We're just going to call that one good and perfect and clean. Okay. Would it be fun to graph? Not necessarily, but what, as we're working through this, I wonder if occasionally you're stopping to look at them and saying, could I graph that? Because the bottom line is if you can understand just a basic parent function, there's not much we can't graph.
But that one there, wouldn't you have to graph it as a log? What's a
No, you could think of it as I'm about to lose you, okay? No, not you. You're too strong for this. I'm going to take the 4 and write it as 2 squared. And then I'm going to raise it to the power of -x over 9. And I'm going to think of this now as y equals 2 to the power of -2/9 of x, like that. And so really what that is just a modification of the basic exponential function. It's got a compression, a stretch horizontally, and it's got a vertical, doesn't have a vertical anything. It has a horizontal flip and a vertical, a flip and a stretch, and that's it. Okay. So I wouldn't want to graph it in that form. But everything can be written, arguably, as a modified version of one of the parent functions, like that. Not bad. I didn't lose you, did I?
no?
Yeah, I figured. We just did that one. We have to do this one now. Okay, I'm switching them again. I'm gonna see if my pencil can hit my. Oh, I'm writing this one like a boss. That's all I had to do is just break the law one time, and now I'm good at it. I feel like a career criminal.
Earlier, I walked into that insurance classroom and I just heard that on the other side of this go. If you cheat, cheat well, and if you lie, lie well. Idiots. I was like,
Hey, these are not terrible words. What do we do first?
whatever.
Divide by 4, right? We're going to get that log by itself. So we're going to have x over 4 is equal to log base 3 of y plus 5. Once the exponential, or in this case, the logarithm is by itself, that's when we know it's time to green light the conversion. So at this point, you can hit it with the water cycle. What's our solo side going to be? Y plus 5 is equal to what?
3 to the power of x over 4.
Dope. 3 to the power of x over 4. And then all that's left is a simple vertical shifter modification for this one. So we're going to have y equals 3 to the power of x over 4, all minus 5. Done. Easy peasy so far. Okay. This will be one more, and then I've got my final push 3. And I maybe we'll make it. I don't know. But again, I'm switching. Math gods, don't strike me down. I'm telling you. So we have x equals log base 8 of the quantity y minus 4 closed quantity plus 6. Just kind of keep hitting the same things, same themes, ideas, just with different little flavorful examples. I'm going to ask you this, and I hope you all know the answer. What do we have to do first?
Get rid of that 6.
Subtract the 6, right? Remember, the log or the exponential has to be isolated. So we're going to have x minus 6 on the left equals log base 8 of y minus 4. And that's the beautiful thing about this relationship between logs and exponentials is that it enables us to take things that are in unreachable locations and make them reachable. Like y right now is screwed. Y is in the ultimate math prison, but by using the water cycle, we can break him out. So y minus 4 is going to break out of jail, get his own side. And what's the other side going to look like? Sweet action. And then, of course, we're just left with adding 4. So we have the inverse y is equal to 8 to the power of x minus 6 plus 4. 3 more examples. I don't know if we're going to make it, but I'm really impressed that we've made it this far. How are you guys feeling? Are you feeling like you can do this? It's not bad. Good. I was a little scared. I'm not going to lie, but I think you guys are.
I remember it being a lot harder last year,
Yeah.
like a lot harder.
Oh.
It really hurt my head last
I
year.
did some.
There's a little, well, we're looking at one very sort of specific little portion of logs, but yeah, anything's easier when you see it the second time. So let's do this one. Y equals.
Oh, you did switch them.
Ay, fart sticks. I'm switching. Math gods, I'm switching. X equals, thank you, Ellie, 3 to the y minus 4 all over 5.
So we do.
Multiply by 5. Right. So yeah, remember, we're not going anywhere until this thing is by itself. And I'm very specific about that. That yellow jelly bean has got to be specifically what's isolated. And the order in which we undo things, we just know from hanging out with people like me in classes like this for years. So we're going to multiply first and get 5x. And depending on your level of comfort, you probably would have also added that 4 across at the same time, like, in succession. So we're left with 3y, and I am going to switch sides here. No, I'm not. I don't want to make anybody mad. So we're going to be left with 5x plus 4 equals 3 to the power of y. And now that the yellow jelly bean is by itself, we're ready to do the conversion. Who's going to get its own side?
Oh, we're gonna get like.
Right. Always remember the exponent gets its own side, right? So we're going to say y equals, and we're done at this point, effectively done. And what is the logarithm going to look like?
Log base.
Or the exponential, sorry.
Or log base 3, sorry.
Yeah, I don't know why I called it an exponential. It's log base 3 of 5x plus 4. And if you submitted it like this, you'd get in trouble. Why? Right. Yeah, you got to express that whole thing is the argument of the log. Do we have time for 2 more? Holy. What's that?
They only give us a minute to do that.
Okay, well then let's go. Let's go again. I'm switching. Following my shot.
So that's like 1/6.
It does.
You would just raise everything to the power of 6.
Nice. Nice work. Yes. God, man, you're good at this stuff. So we're going to raise everything to the power of 6. And so if I exponentiate the left side by 6, I get x to the 6th. If you exponentiate the right side, the parentheses just fall away, which is exactly what we wanted there. We just get 5 to the y plus 6. Everyone clear with what we just did? You okay with Mr. not showing his work up here? And then we're going to subtract 6 from both sides. And we're left with x to the 6th minus 6 equals 5 to the y. And then it's time to hit it with the conversion. Who gets its own side?
Y.
Y is equal to log base.
5.
Of x to the 6 minus 6.
You guys are a remarkable group of learners. Let's see if we can do this. There's one more. Oh, shoot. I ran out of board space. Thankfully, I have a new page. Here it goes. I'm switching. X equals e to the power of x minus 3. Should I save this? Why would I save this for last? What kind of jerk am I?
E to the power of x, e to the power.
Did we not do 3, Mike? Okay.
E to the power of y.
It's e to the power of y. The reason you're a little lost is because your dumb teacher forgot to do the third example. So do you guys remember what a natural log is? Like if I said the natural log of x, are you by chance going to remember that that is equal to the log with a base of e? Oh, there you go. So that's why there's an e in this, because we're going to have to use a natural log when we invert it. So sorry about that. My bad. That was literally on my note card. What a bonehead. All right, so let's see how far we can get. Cooper knows this from the last one. What are we going to do first? Raise both sides to the power of 4. So we're going to get x to the 4th on the left, and the right side is just going to be nice and free and clear. E to the y minus 3. What's the next step?
We're gonna add 3.
Gonna add that 3. So we're gonna have x to the 4th plus 3 is equal to e to the y. And we almost made it, but let's finish. The bell's gonna ring in 21 seconds. We don't care. We're not scared. What's the next thing we do? Give y its own side. So we're gonna say y is equal to
A natural
the
logarithm
natural log
of x to the 4th plus 3.
of x to the 4th plus 3.
3.
Impressive. You guys are pretty impressive. Hey, enjoy your nice long weekend, and I'll see you guys. So I'll just give you the assignment Monday, dudes. And we'll just work.
We need the following students to the office, please. Joshua Keogh and Riley West.
Oh boy. Everybody say bye to Layla. Louder.
Bye, Layla.
Oh yeah.